Hi everyone, in this lecture we are going to solve a problem. We are given an array and we need to write a recursive function that finds the first occurrence of an element in the array. So basically we need to kind of do a linear search and we need to return the first occurrence of that particular element in the array. So let us take one example now. So let's say the array looks something like this and I want to search for an element, let's say 7. Okay, I want to look for this element in the array. So what I can do is if I want to build a recursive function, so in that function I can look at the current element, that is the element at the 0th index. I can check whether array of 0 contains the key element, that is let's say 7. If it does not contain the key element, then I can make a recursive call on the sub problem, that is the array that starts from this point. Okay, so I will make a call on 3 5 7 6 2 and I will ask the array to give me the index of the particular element. Okay, so now here also again we will check at array of 0. We will check, okay, 3 is not equal to 7. We will make a recursive call on the sub problem, that is 5 7 6 2. Okay, again we will see 5 is not equal to 7. We will make a recursive call on the smaller sub problem, that is 7 6 2. Now at this point we look at the 0th element, that is 7, and it is equal to what is the key element, that is 7. In this case what I can return, I can actually return a 0. I can tell my calling function from where I was called that 7 is present at 0th index in this array. Okay, and what is this function going to return? This is going to return that, okay, in the sub problem it is present at the 0th index, then it means in the full big array it is present at 0 plus 1th index, because we also have extra one element here. So it is going to return 1 here. Now this smaller sub problem says 7 is present at the first index in this array. So in this entire array it is present at 1 plus 1, that is at the second index. So it is going to return 2 to this problem. Now this array knows that 7 is present at the second index in this array. This array is going to return to the main that it is present at 2 plus 1, that is the third index in the entire array. Okay, so 0 1 2 and this is 3. So this is how we are going to do the work. Okay, so we are going to ask the sub problem at what index the 7 is present. If the sub problem says the 7 is present at the ith index, then you will return that it is present at I plus 1th index. Okay, so if sub problem returns I, then you will return I plus 1 to the previous function call. That's the whole idea, how we can do how we can pass in the right index to the main. Now one possibility may arise. It is possible that the key was not 7, it was 17, let's say. In that case what is going to happen? We are not going to find 7. Okay, so let's see what happens in that case if the element is not found. So let's say we have an array 1 3 5 7 and maybe we are looking for 16. Now you look at this element, it is not equal to 16. You make a sub call like on 3 5 7. You look at 3, it's not equal to 16. You make a call on 5 and 7. You look at 5, it's not equal. You make a call on 7. And at 7 you see it's not equal to 16. You basically make a call on the null array. Okay, so that means all your array is exhausted. And in this case we still need to return some value. Okay, so we will return, let's say maybe -1. Now this 7 is not going to return -1 plus 1. Okay, if you do, okay, whatever is the result of sub problem, we will add 1 to it and return, then it will be false. So you first need to check whether the value returned is -1. If the value returned is -1, you will pass on the same value. Okay, and if it is not -1, if it is something greater than equal to 0, then you will add 1 to it. So this is basically a conditional, you can say you will put a conditional statement. If your sub problem returns a -1, that means the element was not present and you need to propagate the same -1 back to the parent call. Okay, and if it is not -1, it is something greater than equal to 0, then you will add 1 to that particular answer. So I hope this concept is clear, and in the next lecture I will show you the code for this problem.